In Inquiry 6.1, we're going to be observing evaporation and condensation. Our question for this lab is, how does the temperature of water affect evaporation and condensation? So for your hypothesis, if water is heated up, then it will blank. If water is cooled down, then it will blank. So your choices for those blanks would be the word evaporate or the word condense. So in both blanks, you need to choose if you think the water would evaporate or if the water would condense. Our materials for this lab are found on page 95. Our procedures for this lab are found on page 98 to 100. For our data today, we are going to be measuring the temperature of water, and we're going to pour the hot water in one 2-liter bottle, and we're going to pour cold water in another 2-liter bottle, and then we're going to make observations about what happens. Okay, so I'm going to switch over to the webcam for us to gather our data. Okay, first of all, on the table I have a beaker of hot water, and then I have a beaker of cold water. Okay, when I look at the temperature reading on the digital thermometer for the hot water, the temperature is 58.2 degrees Celsius. And if I look at the thermometer of cold water, the temperature is 17.6. So let's go back to our data for just a moment and put that on our data table. Our hot water was 58.2, and our cold water was 17.6. Okay, now we're going to go back and we're going to make some observations of what happens when we pour that water into a 2-liter bottle. Okay, so I have two 2-liter bottles with lids. I'm going to take the hot water and pour it into this bottle. I'm going to pour it very slowly and carefully so I don't get burned or scalded. Okay, we should start to have some fairly immediate results. Okay, and then I'm going to take the cold water and I'm going to put it in this bottle. Okay, and now we need to start making some observations. Let me move these things out of the way. Okay, first of all, in the bottle that has the hot water in it, we already see some condensation on the inside of the bottle. We see how it has fogged up the bottle, and that's because of the steam from the hot water. But also, the hot temperature of the water will cause the air inside the bottle to get warmer, and then that will cause water to evaporate. The water will turn into a vapor and evaporate. Now in this other bottle, I'm starting to feel a little bit of wetness on the outside of the bottle, and that's condensation. And that condensation forms because the air and the water inside this bottle are cooler than the air around it in the classroom. The air that's surrounding this bottle is a lot warmer. And so you're going to start to have water droplets cling to the outside of the bottle, and that's called condensation. Okay, we're going to pause for just a little moment here and see if we can make any other observations. Okay, let's think about our controls in this experiment. Did you notice how we kept our amount of water the same? In each beaker we had about 200 milliliters of water, and we kept our bottles the same. They're the same type of bottle. We put the lids on them. We kept all of our other conditions the same. So those are our controlled variables. Okay, and what I'm doing is I'm just pausing to give these a moment to see if we can make any other observations before we complete our lesson. Okay, one thing we are going to attempt right now is from procedure step number 7. It says, how does the temperature of the air affect evaporation and condensation? Try this. Rub the ice cube on the outside of each bottle, and what happens? Then rub your hands on the outside of each bottle. What happens? So I'm going to take an ice cube. I have some ice cubes back here in this little container. And what I'm going to do is I'm going to rub the ice cube on the outside, and you will notice, maybe you can see, notice that it's quickly melting the ice cube. That's because the bottle is very warm. That warm water we put in there warmed up the air inside the whole bottle. And as you can see that water running down the bottle here. That's because it's quickly melting the ice cube. And did you hear that? The bottle just popped, and that's because of the change in temperature. It's very hot on the inside of the bottle, and it's cold where this ice cube is being held. And you may notice, I don't know if you can see it from the video, but there is a little bit of the little smoky fog like you see when you breathe out on a cold day. Some of that was coming off where the ice was. And you probably heard the bottle just then pop again. And notice that the bottle is sinking in right here. Okay, let's try that with the cold. I'm going to get a fresh piece of ice. And if we rub the ice cube on the bottle, it's actually pushing out. It's pushing out on the bottle instead of collapsing in on the bottle. It's actually pushing out. And the ice is still melting, of course, because my hand is warm. But if you'll notice, it's not melting quite as fast. But do you see this foggy area right here where I've been putting the ice cube? That's because it's pulling. Oops, let me see if I can. Sorry, this is backwards to how I'm holding it. Can you see the foggy area on the inside of the bottle, right where I am putting the ice cube? Now, all of these things I'm showing you are things you can write down in your observations. Okay, so let's go back to our data table. I'm going to switch back to our data table view. Okay, on our data table view, you would write some of those observations here of what you noticed with the hot bottle and what happened in and around the cold bottle. Okay, when you get through making your observations, you are going to read hurricane formation in the water cycle on page 98 to 99 in the textbook. It is just a very short little passage. Really, it's just maybe 2 paragraphs and 2 pictures. So if you'll read that, that will help you to answer the questions. Because in this lab, we need to focus on the water cycle, because we've talked about evaporation and condensation. So make sure you pay attention to the pictures that are part of that reading selection. Okay, when you finish with that, you need to scroll on down to your vocabulary. You have 2 words, condensation and evaporation. And then you need to write your conclusion. Your conclusion should be a paragraph about 5 sentences long, and it should describe what we found out about how the temperature of water affects evaporation and condensation. And make sure you use some evidence from your observations to back up your conclusion. All right, y'all have a great day. See you soon.